All right, so our recording should be in process. Yes, it is. Let me thank everybody again for joining us today. Today we're going to talk about what we call easing CNC with SINUMERIK Operate, specifically on ShopMill. So this is going to be a 3-axis milling application. We're going to talk about basics of setup, jogging the machine around, whatnot, and we're going to get into programming, and we're going to use the ShopMill conversational package to actually go in and program a part. We'll even be able to go as far as run it in an auto mode. I'm your presenter for the next hour, hour and a half, Chris Pollock. I'm a dealer support specialist with Siemens, covering the East Coast territory. My contact information is here on the screen, so by all means, you guys can always feel free to contact me, certainly after the webinars are done, if you have any further questions. Our online live seminar, this is a pretty new program that we've just really rolled out over the last few months. Just trying to be able to get a better medium for people to be able to continue to educate themselves on the Siemens product. So the seminars will cover the full range of controls that we offer, anywhere from our 840D down to our 808D control. Just to give you an idea of some up-and-coming events, certainly we have the one we're on today. The next up-and-coming would be commonality between ShopMill, Program Guide, CAD/CAM, and ISO mode. So just as a quick little teaser on that, basically what we're going to do is we're going to take a basic job, simple 2.5D machine part, but we're going to methodize it, programming it in 4 different modes. So we'll certainly do it in conversational, but then we'll do it in G-code through the Program Guide mode within Siemens. Then we'll see one that was programmed in a CAD/CAM system and how we can utilize that and bring it in and run it and simulate it. And then as well, we'll look at our ISO mode, which is an ISO G-code compatible mode. So it gives you a really good understanding of kind of all of the different ways you can methodize a part within the Siemens control, and then you can kind of fit the control to your needs. That's going to be this December. There will be an email blast sent out promoting that in a few weeks here. After that, we're going to do some 808D milling in probably late January, early February. And then we're going to get into starting to do some specific G-code programming sessions. A lot of time we have a tendency to strongly emphasize the ShopMill and ShopTurn side of our control, but we also want to pay attention to the G-code side of our control through Program Guide. So we're going to have some for turning and milling coming up in the near future. I wanted to take a second to just let everybody on this webinar or seminar be familiar with where they can access the data. What happens is, just like I initiated now, all these seminars will be saved or recorded, and then they are posted on this website. So we have 2 core website links for you. They're all based on the same website. The main page is the CNC for You website link that you see here in front of you. And then from there, the direct link would be the one below it. So if you went to CNC for You, you can find a webinar link and it'll bring you over to this page, or you can just directly hit that. So from there, you're going to see not only the previous, you can view the recordings from the previous seminars that I've hosted in the past and other Siemens employees have hosted, but you'll also have, the first one will always be whatever event is up and coming. So you can also register, or you can direct people to this site and they can register for up and coming events just by going directly to this site. So hopefully you guys will find it to be a good resource. Today, we're going to be concentrating on basically the 840 and the 828 control systems. So everything we cover will apply directly to either of those controls. So no matter which system you're utilizing, everything we cover really is pretty much on exactly that for either of those 2 controls. The 808's a little different flavor. So some of the stuff that we're going to be referring to today may not actually exactly apply to the 808, but all the things we're going to do today can be directly used on either of these 2 platforms. Okay, so now at this point, this is just a quick little overview of kind of what we're gonna do today. So here we're going to talk about ShopMill in a 3-axis application. We're certainly going to look at moving the machine around, jogging around, as well as writing a program. This is going to be the primary example that we use when we get into creating a program. So it certainly covers a bunch of different processes that you would normally do on a milling example. So we'll do some profiling. We'll face off the part using a CAN cycle. We're going to go in, do a bolt-hole pattern, probably center drill, and then come in and counterbore these holes. So at the end of the process, we'll have not only maybe run a routine and looked at setting a 0 on the part and finding the part 0 and maybe touching off some tools, but we'll also go in and write a program and run it in auto mode. All right. So first thing we're going to talk about is our jog mode. And our jog mode is generally the first screen you usually see whenever you power up the control. So this is an example of the jog mode. Within the jog mode, we're going to explore a bunch of different functions, but one of the first functions we're going to look at is the TSM function window. The TSM function window allows us to do such things as change tools, fire up our spindle, maybe select other M codes, change planes, a lot of the typical commands that you might be used to doing on other renditions of controls in an NDI format. We have the TSM screen that handles that. You can use MDI, we can look at it briefly, but TSM keeps you from having to really worry about a lot of those very traditional G&M code types of structure. Okay. From there, we're going to look at setting work offsets, setting tools. So here you just see a couple quick examples of those two core functions, and those are certainly functions we're going to do quite commonly on a system, finding a 0 or setting up our tools. Once we've gone in, we're going to explore the offset table. Where do these offsets go to? As we use these different functions, they're writing to certain screens or areas. So we want to explore that a little bit to kind of get you familiar where the data itself is going. So we'll look at that. We'll also maybe create some tools, see the offset table, talk about some of the features within the offset table. So from there, what I'd like to do is I'd like to switch over to what I like to do is consider as a live presentation. So what we're going to do is we're going to bring up, and I'm going to share it right now, a piece of software called Sinutrain. And what Sinutrain is it is a machine emulator. Basically, it mimics the control, but it's running here on a PC. So everything I can do right on the machine tool control, I can do here. Everything's fully functional, so I can actually grab my override knobs and adjust my overrides, and you probably see the displays changing and the knobs moving around. I can do the same thing for my override here on my feed. I can flip through screens, I can jog the machine. So we'll talk about this for a minute or so, just to kind of get you used to what's going on here. Okay. So when you first power it up, I mentioned that most likely you usually see the jog screen as your first screen. With that being said, some machines that require referencing, like a homing process, may initially power up viewing the reference screen. At this point, you would probably initiate some reference procedure that was given to you by the builder. There are a couple different ways you can reference the machine. That's certainly something that the builders decide what they want to do. But from there, the next usually logical step would be to select the jog button, brings us over to the jog mode. So jog it does exactly what you're thinking it does. You can jog the machine. I can move the machine. So here, certainly I can't show in Sinutrain an electronic hand wheel, but if I had an electronic hand wheel on the machine, I could grab it and start spinning that hand wheel. Here, if I want to jog, I can select the axis I want to jog, and now my plus or minus keys are active, and I can start moving the machine around. So this would be a simple way of certainly starting to move the machine around, get it to some location, select my y-axis. I can start to jog my machine around. If I want to go define distance, I can use the increment variables here. So you have 1, 10, 100, 1 starting out at a tenth every click, a thou, 10 thou, and right up through. These are usually the same increments that get supported with a remote hand wheel as well. So if you want to do something a little bit finer, where you want to get close and just slowly increment in, now each time I hit my plus or minus key, it's going to move this defined distance. If you want to clear it, just simply hit the jog button again. That'll clear that distance, and now the machine can be jogged again in a variable mode, so it'll run as long as I'm holding the button down. If your machine is equipped with it, the rapid button sitting between the plus or minus will just increase the speed at which it's jogging while you're holding that rapid button down. So you would physically hold the button down, then you would start to move it with your plus or minus keys. So we're obviously interlinking it here in Sinutrain. Okay, so what we're going to do is first we're going to talk about tools, and we're going to maybe create a simple tool in my tool table, and we're going to load that tool into the spindle, and then from there we're going to set up the tool and set up some offsets. So let's say, for argument's sake, the first thing I want to do is set up my part 0. We put a part in my vise, it's sitting there, I want to grab an edge finder, I want to come in, I want to change that edge finder. Well, I need to know what's in my spindle. So from that, I'm going to look up at my TSF field, that is up in the upper right-hand corner, and I can see whatever tool is physically sitting in my spindle. In this case, I have a 3/8 end mill currently in my spindle. The left of that is my workpiece position display. So this is going to give me my coordinates. So as I zero out the machine, you're going to start to see these values start to zero out. And then I can use any of my horizontal or vertical soft keys to maneuver through our functions. So I said I wanted to change my tool. I want to change from a 3/8 inch end mill to an edge finder. One way to do that is to select the TSM button in the lower left corner of the screen. And when I go into TSM, I have a bunch of options. So you see where the orange field is? This field can be maneuvered around with my blue arrow buttons. So on the right side of my panel, I can move my cursor up or down to get to a location. So within here, I can do tool changes, I can do spindle functions, I can do alternate M functions, I can load work coordinates, machine planes, a bunch of different things I can do within this screen. So the first thing we're going to do is we're going to change the tool. Is this a live field? Absolutely. I could certainly start typing a name of a tool, a number of a tool in this field, hit cycle start, and it would change the tool. But what you're going to notice with Siemens is we allow you to get a little more elaborate with the names of your tools than traditionally used in most controls. So with that being said, to keep it from becoming very clumsy as to how I'm typing in this data all the time, we created a mechanism through this select tool function. So in the upper right-hand corner, you have the button select tool. By pressing select tool, it's going to bring me to my tool table. And this is your first opportunity really to see the tool table and how it's made up within the Siemens control. So with this being said, I can start to move my cursor up or down with my blue arrow keys, just like I did before, and I can find a tool or I could create a tool. So what we're going to do, we'll do our first tool change to a tool that already exists in my tool changer. And that happens to be an edge finder, and I see that down in pocket number 1. So simply highlight the edge finder, and now hit the In Manual button. And again, that's in the upper right-hand corner. So it goes to the same position of button I just selected. Now I'm going to hit In Manual again, and you'll notice what it does is it fills out the tool name for you. We've created this mechanism throughout the control when I'm writing programs with a G-code or Conversational. So I only have to type the name in once. Once I've typed it in, I don't have to worry about ever typing it in again. You can imagine having to type in edge_finder every single time I want to change this tool would be cumbersome, hence why the mechanism was created. Once I've selected the edge finder, I simply hit cycle start. That will initiate your tool change sequence. If everything's happy and it made it, I'm going to see edge finder in my TFS window, and now my edge finder is loaded. What does the machine know? Well, it knows the diameter of the edge finder because I had given it that. It knows the length of the edge finder. In this case, no length has been set up, and normally you wouldn't on an edge finder, but certainly it could be, and that would be known there as well. Another common function I'm probably going to do within my TSM screen is start up my spindle. So I'm going to use an edge finder. I got to have it running, so I'm going to type in some RPM. Now, when it gets to the spindle M function, you're just going to simply hit the select key, toggle the direction. I can position with this as well. So I'm going to run it at clockwise. I'm going to hit cycle start. Spindle fires up. The spindle's running. So now I have some other options. I could certainly fire up my coolant if I want by putting an 8 here for an M8 command. I could toggle to a different work offset if I wanted to toggle to a different work offset. All that stuff could be done within the TSM screen. So once you have an edge finder selected in the spindle, I'm just going to hit the back key to come out of that function. And now I'm going to go to my measure workpiece function. Now, there are two ways to actually set a 0 within our control. You can do a set work coordinate function or a measure workpiece. So set work coordinate is a pretty standard, straightforward 0 set. I move to some location. I want to establish this point as 0. I simply come in, hit X or Y or Z, whatever I'm zeroing. In this case, maybe X, and it immediately zeroes at the display. I see in my workpiece display the coordinate value go to 0. Now that offset's been set. So what actually happened? Well, the system, basically, it measured or read the distance it is from its machine coordinate 0. That's where the machine would be referenced from to the location I'm currently at, and it wrote that value into an offset table. That offset table can be found by hitting the offset button right over here on the right side of your screen, right next to program, and that'll bring you back to that tool table we were just in. But now I want to look at work offsets because I'm creating a work offset. So I'm going to select the work offset horizontal soft key. I first come in, it's showing me whatever work offset's active, but I can also look at all of my work coordinates by hitting my G54 through whatever I happen to have selected on the control. We support up to 99 offsets. And here I see this is the distance the system calculated. So I have a negative 6.5722. So with that being said, if I'm in this field and I was some distance away from that edge, 100th thou, 1 inch, whatever, you can actually type into this field. So maybe I type 1.5. That gives me my current position. If I was to go back to the offset, I see that the value now changes. I was at negative 6, now I'm at negative 8, and so on and so forth. So I can certainly use this type of function to set a simple 0. But what we also done is we also incorporated a bunch of measuring cycles into the control that aid for more common part 0 setups. So in this case, I can do a simple edge kick. I come in with my edge finder. I bring my tool over to the edge of the part. In this screen, I decide which work coordinate I want to set. So any one of my potential 99 work coordinates. I define the measuring direction. I always want to make sure my little picture, this is what we call an animated element. It's a little help screen for you. I always want to make sure it matches the way I'm actually moving the machine in the real time. And then I define what the edge is going to be when I'm all said and done. Now in this case, I have a 200th thou edge finder sitting in my spindle. So when that edge finder touches the edge, I'm actually 100th thou away. So if you simply hit set work coordinate, see how it automatically compensates for the edge or the radius of the cutter? So it's just really simplifying what we're all probably used to having to do in a couple steps. You know, come over, set a temporary 0, move up, move over to find center line of spindle, set the 0 again. This one easy little function will do that for you automatically. We take it to the next level, however, and give you a whole bunch of aided functions within the control to aid more complex setups. You know, like this spacing 2 edges. I can touch my edge finder to the left side, touch to the right side. The system will calculate the middle of this block and establish a 0 there, or any value you want to be to center. I can find skew of a part and establish a 0 in a lower corner. I can find the center of holes. I can find the outside of a boss. So, in this case, I had a rectangular part and I want to establish a 0 dead center. I can come in, I can touch 4 points. The system will automatically calculate the center for you. Now, what's unique within this measure workpiece function is how it works. Right now, this is all manual. And it's manual because I have a manual edge finder in the spindle. If I was to tool change to a probe, if I happen to buy an electronic probe or a 3D probe with my machine tool, 2D or 3D, there's a couple options out there. Then what happens is all of these cycles we're just looking at now become automatic probing cycles. So they do the same routine, but I don't have to move the machine. I would just simply position my probe somewhere close to the edge. Then I would hit cycle start. System would automatically come over, edge find that part for me, and write the offset to the exact same spot, which is my offset table, my work offset field, and it would type in that value. So you could do that for any of these cycles. So what we're giving you is we're giving you probing cycles built into the control, but they're probing cycles that can be used either manually with an edge finder or an end mill, or fully automated if you happen to have a probe in the machine. So I go to a hole, drop the probe roughly in the center, give it a rough diameter, contact angle, and what I want to establish is 0 to be or the center to be when I'm done. It'll do that for you. Okay, so then from there, the next step is possibly setting up a tool. So I would use my measure tool functions for that. Let's just tool change really fast into a end mill. So let's say I had a 1/4" end mill, cycle start. Now when I go to measure tool, you have 4 different options. I can do manual or automatic. So automatic would be if I had a presetter equipped on the machine. Manual, I would physically bring the cutter down to a datum, whether it's the top of my workpiece, whether I want to create a fixed plane, and then have all my tools adjust to a new surface with a work offset. You can do that. Most guys, especially when you're first getting used to the system, will just set all your tools to the top of a part. So here, I would manually move the machine down, bring it down until it was touching the top of the part, and then simply tell it what I want that part to be considered. If I knew I was taking a facing cut, maybe I want to tell it I got a little bit of positive material. I can type that. I hit set length. You see that the offset now changes to 30 thou. This is critical within our control. We automatically load any offsets that have been changed once they've been changed. So you always want to make sure that when you look, the number changed. A lot of controls don't do this. A lot of controls force you to have to reload the tool offset or the fixture offset once you've made any corrections to it. We do not. We load them on the fly. Same scenario. If I didn't see the number change, I probably did something wrong. So, here just to show you again, maybe I want it to be 15 thou. Set length. See how the 15 thou automatically represents here? So from here, I can start touching all my tools off. You don't always have to go to TSM if you want to do tool changes. You can do it right within the measure tool function. So with my highlight at the T field, I can hit select tool. I can grab another tool in manual, cycle start, initiate a tool change. I move down, establish where the top of my part is, set my length, see my offset update, and I can continue that process for however many tools I happen to have for this job. What is it happening right there? Where is those values going? It's going back to the offset table, but it's going to the tool list. So if I scroll all the way up to the top of my tool list, I see the engraving tool. This is the one that happens to be in my spindle, and I see a length of -13. This value was just calculated by that function. There was no number in here before we started. It put it in there. I also did the 1/4" tool. So there's a drill, 1/4" end mill right there. There's my 16 inches. So that was what got set when you use that function, when I use my measure tool. You can do manual diameters as well. It's not as common. Usually if I'm going to do it manually, I would just mic up my end mill or my tool and physically type the number in the offset field when I created the tool. But you could. And then if you happen to have a 3D probe, a tool probe, then the tool probe has the ability of measuring the tool. Okay, so what we want to do here is we want to, sorry guys, I jumped to the wrong one. We want to continue with our PowerPoint. And we are going to start to take a look at the next section of screens and functions we want to cover within this webinar. So first thing we wanted to certainly talk about, just as a brief overview, is how to do a simple setup on the machine. But the next thing is, how do I get in and create part programs? Where are my part programs stored? How do I get to that area? What different mediums can we store part programs on? How do I move them in and out of control? That's all handled through our Program Manager function. So somewhere on your front panel, we have all sorts of different renditions of front panels within the Siemens world. But somewhere you're going to find a Program Manager button. If you can't find a hard button, you can always hit the menu select key, and you will get a soft button that represents these as well. And I'll show you that as we're going in. So when I go to Program Manager, we're going to start to see all the different areas, the folders that are automatically there for you, and then some of the subfolders I have the ability of creating. We'll talk about using USB. We'll talk about a little bit about a network drive, maybe extended memory. So those are a couple of things we're going to review here in the live session. Next, we're going to go in and we're going to actually talk about creating directories, maybe creating a part program, how that whole thing works. We're certainly going to make a part program here. We're going to talk about saving data. One of the key functions within the Siemens control is we not only let you save your part programs, but you can save the tool and the offset data. So as you create an elaborate tool table, that can be saved as a file. That can be brought out of the machine, brought back in. And it looks something like this. You use the save data function, and you come in and you actively go through these steps, and it will build a file for you. Once we've created a part program, we're then going to immediately segue into physically writing the program. So we're going to look at the first header page, and we're going to be writing a ShopMill program. This is all conversational based or feature based, as we like to say. Then we're going to go into the event editor. This is how we're going to add functionality to our program, as well as keep track of what we've plugged into the program so far. We can make editing changes and whatnot. Once we've done that, we're going to go in and start using our CAN cycles to do different functions. Like in this case, we're probably going to do a facing cycle. Gives you a good example of a facing routine. Once we face up the part, we're going to machine an irregular contour. So we get a chance to see the contour editor for creating irregular shapes. Once we've done that, we will certainly go in and simulate the part. You'll get to see the full 3D simulation that's within the control. We'll just be able to show you with a path, without a path, maybe some other sections. All right, and then we'll go in and we'll actually do a live demonstration of everything. Okay, we did have a question come in, so we have a quick second. I could probably take this question. How is it possible that Sinutrain filled in the measure of the tool? Is there a virtual chuck on the machine? Well, the measure of the tool, if you're talking about in the length, is strictly just a function of the distance from wherever the machine reference is to really where the system's currently sitting. So, if I go back to Sinutrain here, everybody should have that refreshing on the screen. When we were using the measure tool and we're using the length manual function, I moved the machine down. I moved it to some position relative to the machine coordinate system. Your machine coordinate system, and I can actually turn them on right here, this here is where the 0 of the machine is established. So we have a lot of machines with absolute encoders, certainly plenty with incremental encoders. The difference is with an incremental encoder, the machine has to home or reference when you first power it up in the day because it doesn't remember where it is. On an absolute system, it knows when you first power up. But even though it's an absolute system and it knows where it is, there's still an established reference point that was first set up when they set up those encoders. So all it's doing when you do the measure tool function is saying, hey, I know where my 0 of the machine is. I know where you're currently telling me you want this 0 to be. I'm just going to write that offset physically into the tool field. So that's how it does it. Hopefully that answered your question. Okay, so we're going to continue on here. We're going to talk about our Program Manager. So I select Program Manager, and it first brings me over to the program area or directory. Generally, when I first come into Program Manager, I'm going to see the NC folder. So NC, if you look in the lower left-hand corner of my screen, just above my stop button, And when I refer to the screen, I mean the machine screen. Everything in gray here is really a representation of the machine screen, and then all the buttons around the peripheral are the manual panel of the machine control panel. So this would be your e-stop. So when I do refer to lower left-hand corner of the screen, I'm not talking about the PC screen. I'm talking about the machine represented screen. Okay, so NC is where all of your programs that are sitting in active memory are residing. So what that means is we give you 3 different core folders, and in these folders I can create basic part programs. These would be MPFs or main program files. I can create subprograms, and in there they would have an SPF extension as a subprogram file. Or I have the ability of creating workpiece folders, and inside a folder I can have main program files, I can have subprogram files, I can have offset files with different extensions. So it's really kind of up to the user, how you want to track or where you want to place your part programs, how you want to manage them, so to speak. You know, a lot of guys will use folders if they're doing specific jobs or specific customers. Sometimes guys just like to dump everything in part programs. Now, part programs has to be a main program file. We will only support anything other than that. Same thing with subprograms, they have to be a .spf extension. Outside of that, though, when you get to your own folders, you can mix and match. You can have any type of extensions. We support PDFs here. You could bring drawings right into the control, but all that stuff would have to be sitting in a workpiece folder, as well as your main program files could be down there. So the other option I have, and this is an option, would be a local drive, and that's just an expanded memory. So if you happen to buy the system with expanded memory, we give you a partition. The size of the partition does vary. The older controls, I think it used to be a couple hundred megabytes, maybe 256. I want to say the current control platform, it's a 2 gig partition. So it gives you a decent amount of space, and then depending on the hardware platform, they can actually go up from there. But this would be extended memory on the control. From here, you can certainly create folders, and you can have different file names in those folders. So the structure can look like it looks over under workpieces, but this area isn't using up your RAM or your active memory. This is external to that, so that's what we call our local drive. You can certainly use USB. So if I plugged a USB into the system, this USB button would go black, and then I can maneuver programs back and forth. The USB can be used as an external hard drive, so you could run programs from it. We do caution you, though, when you are going to try to run from a USB, because for one, just the USB platform itself isn't the best of connections. You only have 5 little tabs that are spring-loaded. 2, it's just sitting in a front panel, so God forbid somebody popped it out, then the system would stop. Certainly wouldn't stop immediately. There's a buffer, but it would stop within the buffer size of your machine, and then you would be stuck. And then the third, which is really the more common issue, is there's a lot of cheap USB sticks on the market. And guys tend to use whatever free stick they got from the last class that they maybe were at. So with that being said, that can certainly affect the quality of the drive. So be careful. You know, would I use a USB if I got in a bind and I had a program that couldn't fit in memory and I need to run it? Sure, absolutely. I just wouldn't make it a normal process. Now, the other thing I could have is I can create my own subfolders. In this case, this is just a map directory on my hard drive. But if this was a network, this could be accessing a network partition on a server somewhere. So with that being said, I can select a drive. I can maneuver programs back and forth. You know, let's say for argument's sake, I wanted to come into some area and maybe take a program. So highlight the program. Maneuvering or moving programs back and forth is a simple cut, copy, and paste, so what we're all used to in Windows. So once I've highlighted a program, I can hit copy. I can go over to some specific area and hit paste, and I just move the program. But the beauty of our control is we actually allow you to manage these programs anywhere within the system. So even though I'm on a network drive, I could edit the program, I could run the program. So in a lot of respects, if you have a network, there's no need to even bring the file into the control. Everything could be run remotely if you wanted to. A lot of guys that deal with very large files will typically do that. They'll leave the file sitting on the network drive and then just run it from there. As well, I certainly have all my cut, copy, paste commands. I can go into properties when I expand my vertical soft keys by hitting this double blue arrow. And properties allows me to not only rename a program, but if I'm accessing a program that's sitting in RAM or in active memory under NC, I can start to create my access rights for the program. So maybe I don't want my operators to be able to edit the program, but I want them to be able to at least look at it. You can start to do all that stuff with your programs. You can start to control the access rights of a program. Other areas or functions we have, I mentioned earlier, to creating, if I want to create a backup of my tool table or my offset table, that's done through this archive function. And I can go into setup data, save setup data, and then fill out this page, hit OK, and what the system will do is it'll create a file. In this case, it created this INI file, and that file is a backup of my tool table. When I'm highlighting the file, if I just hit my blue arrow to the right, it initiates a read-in process. So if it was time to load that tool data, I would just say OK, and it would rebuild or reload this offset table. So that table we were playing with, all the work offsets, magazine locations, tool lists, all that stuff would be rebuilt by this INI file. Now, it will wipe out the file that's there. So when you are doing this, be aware that it's going to overwrite the current tool step. So usually it's if I'm doing a complete changeover, maybe from one part to another, one series of jobs, would I do a function like this. You can also delete files here. If I had a file I didn't want to save, I could do that just by hitting the delete key. And then we do have a mode called multiple clampings. And what multiple clampings allows us to do is I can take a part program that was written in the machine, whether it be in a conversational system, and I can tell it that I want to basically take that part program and run it on multiple workstations. And it'll create a new program for you that optimizes all the tools and methodizes that part instead of being on one device on maybe 3 or 4. So that's the multiple clamping. If anybody has questions towards the end, if we want to spend a little more time on it, if we have the time, we certainly can. Okay, so what we're going to do is we're going to get in and we're going to actually create a part program. So I'm just going to be in NC. I'm just going to go to part programs in my case here and create a simple part program. The way I initiate a new program, I want to be back to my original vertical soft keys. So if you're left it one layer in, just hit the double arrow and it'll bring you back. And I want to select the new button. New is immediately going to ask me if I want to create a G code or a conversational program. Now, there is an additional option up here, directory, and that happens if I'm in the workpiece area if I want to create subfolders. So it's the same new, whether you're creating a part program or a subfolder. In this case, since I'm in part programs, we don't support subfolders in part programs, only MPF files, like I said earlier, so you only have the option of ShopMill or program guide. So in this case, I want to make sure ShopMill is selected. We're going to type a name. In the Siemens world, we support letters, numbers, and underscores. Nothing else when it comes to a name. I believe it's 24 characters if memory serves me, so we certainly support a pretty large name, but you don't want to do any minus signs, forward slashes, anything like that. A letter, number, or an underscore. So maybe I want to call this ShopMill underscore sample underscore 1. So you can see you can get pretty elaborate with your names. Again, letters, numbers, underscores, nothing else. I do not have to put the extension. It will automatically put that there for me. So at this point, simply select OK, and it will start to create our ShopMill program. So when I'm writing ShopMill programs, the first thing I always see is what we call our program header or our header screen. So that is the screen you are currently looking at. I didn't do anything other than just say OK or yes, and it initially started creating this ShopMill sample 1 program. And in here, this is all of the very typical modal commands that we need to always see on every part program. So first question, or first thing it's asking me is, what work coordinate am I using? Am I not using any work coordinate at all because it's established somewhere else? Like maybe I'm calling this program up from another one. Am I using our base reference, which is our first 0 shift from the machine coordinate system? Or am I picking one of the work coordinates, any one of these work coordinates? So maybe I decided I wanted to pick up 55. Now, a lot of times what you'll do on the machine tool is just hit your select key right here in the middle of your blue arrows, and I can toggle to any of my work coordinates. Same scenario, if you just simply hit any one of the keys on the keyboard letter, it will automatically bring up a sub-window, and then you can move your highlight up or down with the blue arrows to select a given work coordinate. Once you've defined the work coordinate, the next question we ask is the blank. Now, this really is only for graphic purposes. So when we get to simulation, we want to have a representation of what the rough stock is. So I can pick cylinders, I can pick pipes, I can pick blocks with the center being 0, 0. I can do a standard block where I define 2 opposing corners, define either lower left, upper left, lower right, it's up to you, and then we can figure out the size and shape of the block that way. Obviously, the block's always going to be some form of a rectangle. I can do hex stock or none if maybe I'm calling this up from another program or I'm not using graphics. So we're just going to do a simple block center because in my example, and I'm going to bring up my example real quick. Hold on one second. We'll just show you as a refresher. In my example, we're going to establish the center of my part. Oh, I'm sorry, I haven't shared this one yet. Give me one second. All right, so hopefully everybody's going to see. There we go. Everybody should now see the print. So in this example, we're just going to leave the center of this part to be 0, 0. Maybe we'll say that the rough stock was 4 1/4 by 4 1/4. We're going to machine this basically to a 4 by 4 block with some chamfers and radiuses. We're going to face it off. We're going to put some holes in it. So this is going to be our part. So what I'm going to do is I'm going to keep this over here in the lower left corner. So hopefully you'll get to see at least the profile of it, and we might pop it up every now and then if we need to review it. But just so you can see some of the dimensional data as I'm starting to plug in these numbers. So I'm going to use a block center, as I just said. And I did mention that we're going to say that it's 4 1/4 by 4 1/4. I certainly don't have to retype these. I'm just doing it for your benefit. So this defines the width and the height of the rough stock. From there, I'm going to establish my 0. Now, it doesn't have to be, but most commonly in the industry, we establish the top of the part to be Z0. Anything into the part's a negative, anything above the part's a positive. So with that tradition kept in mind, a lot of times if I know I'm facing up a part, I may leave a little bit of plus material in the Z. So that's all we're doing here. We're telling it, maybe we're going to leave 30 thou, let's say, in the plus Z. So once we face it off, the top of the part's going to be considered 0. Then we have our overall thickness. So this part, if I bring it back up again, the overall thickness is 787 is our finished thickness. So I'm going to obviously give it a little bit more. I'm going to tell it that we have minus an inch of thickness in the part. And then from there, you'll see what we're clamping on and then what we're machining. Tool plane, how does my tool sit on the system? So 17, 18, or 19. Now, a lot of people think that the tool plane is here to strictly control my arcs, my G2, G3. But what the tool plane actually does for us is it also establishes how all the can cycles work. So I can change the system like if I had a right angle head, and all my drilling cycle, all my pocketing cycles, everything will work in this tool orientation. So it's very important that we get the correct orientation of the tool. So we're on a standard vertical mill. We're going to leave it at G17. Retract plane, where do I want to go when I'm done with this cycle? So whether the cycle's drilling or the cycle is a pocket or whatnot, where am I going to go when I move up? Safety distance, how close do I want to get to the part before I start feeding into my part? So here we got 100 thou safety distance. Now I have my machining type. Do I want a climb mill or conventional mill? So we're going to down cut is climb mill, up cut is conventional milling. We're going to climb mill. And then how do I want to handle my drilling? Do I want to always retract to my retraction plane, which in this case is 1 inch above my part after every hole? Or do I want to just back up to the safety distance? And that'll certainly vary based on multiple planes, if I'm drilling multiple planes, because that's an incremental value. And then just go to the retraction plane when I'm done. So it depends on fixturing and clamping, but that's what those functions do. So we fill out the page, we hit accept, we save our first event, and that's your program header. Now, any of these events, if you hit this little arrow here or use your blue arrow to the right, you can open up the event, make a change. Like maybe I wanted my retraction to be 1.5, hit accept, and you just updated that event. So the first operation we're going to do is we're going to face off this part. So what I'm going to do is I'm going to use my horizontal soft keys, and I'm going to go to milling. In milling, I have a whole bunch of can cycles. Certainly, we don't have time today in this short format to go through every single cycle. So we're just going to hit a couple of the most common. So in this case, we're going to use face milling now. We are going to go into pocketing to do our little counterbores on our print. In drilling, we'll do some center drilling and drilling. So in this scenario, I'm going to go over to face milling. And now we're going to start to fill out the page. So the first question is, what tool am I using for this operation? So this is where I'm going to use that same mechanism I used in TSM. I'm going to hit the select tool key. And in this case, it is going to show me an abbreviated version of the tool table. But maybe a tool doesn't exist, or I want to get to the full tool table. I can hit the tool list button one additional time. Drills me all the way back. Now I can come in and find my tool. So I look to see if I have a tool there. I had one made already for now, just for speed's sake. We'll use this one. Maybe the next tool will create one just so you get a chance to see creating it. So in this case, if I'm using an existing tool, I just make sure I bring the highlight up or down with my arrows, or if you have a mouse, you have the luxury of clicking on the tool. But once the highlight's done the physical tool, simply hit to program. It's going to fill out that tool. Next, you're going to give it some feeds and speeds. So within the Siemens world, and if I go back to the tool real quick, you can see it. One of the things that you do when you create a tool is you tell it the number of flutes, number of teeth. So we know the diameter of the cutter, we know the number of teeth. At some point, we'll know the length once it gets set up. So with that being said, we have the ability of not only programming in inches per minute or feet per minute, but I can program in feet per tooth. So here I can tell the system, hey, I want to go at 6 thou per tooth. RPM, I can do straight RPM or constant surface feed. So maybe I want to run at 600 surface feet based on the inserts I'm running on this tool. If you go back to the two fields and hit select, it'll show you what the calculated RPM and the calculated feed rate would be for those conditions. So in the Siemens controls, you can program either inches per minute or feet per tooth, as long as you gave us the correct tool data in the tool table. Okay. This little triangle defines whether I'm roughing or I'm finishing. So in this case, I want to rough it out. Roughing would be if I wanted to take multiple Z depths. I can control my cut direction. So I can do unidirectional, bidirectional. Is it oriented in the Y? Is it oriented in the X? I have a whole bunch of different scenarios. And then I define basically two opposing corners. The top of my part, the other corner of my block, so it knows the width and the height of the block. What position do I want to go to when I'm done? So this is an absolute location. See how it says absolute right here? You could toggle the select key and make it incremental, but now I would need a value based on this 30 thou down. But if I'm an absolute, I'm saying, hey, I want to end up at 0. So I'm telling it start plus 30 thou above, end on the top of my part, which is Z0. DXY controls my step over. I can have a percentage of the cutter diameter or a physical value, a linear distance. So I'm going to do a percentage of my cutter diameter. It's how much it steps over. It says, does it zigzag? Depth per pass. So if I leave it at 25 and I had 30 thou on, it's going to take 2 cuts. The last remaining cut will be 5 thou. And then do I want to leave material for a finish cut? It won't take this. You would have to go back with a finish cycle to take that final cut if you wanted to do that. In this case, I'm going to let it bring it right to size. You can use these modifiers on the sides if maybe you didn't want that tool to overlap a given edge. Maybe there's a stop there or a clamp. That's why those are there. And on any of these events, all of our documentation is built right into the control. So if you simply hit the Help button, it will bring up the page of documentation specific to the event you're in. And you can even go to a full table of contents. So all the manuals are built into the control automatically. And simply just hitting the Help button will get you to those manuals. So for our scenario, this would be an acceptable page. So I can fill out all the information and hit Accept. And now you see you have another event. Now the insert, it always inserts below wherever this highlight is. So you always want to keep track of your highlight. If you get it to the wrong spot, like if I move my highlight up to the header and I forgot to move it down, I would start inserting events between the program header and the face mill cycle. Okay, so I have a face mill. We can continue moving on with the program. So let's say, for argument's sake, I want to maybe contour this part. We're going to machine around the outside of the shape of this part. So for something that's not symmetrical, certainly if this had consistent radiuses in all four corners, I could just use a pocketing cycle or a spigot cycle if I want to leave it like a boss standing. But for something irregular, I'm going to use the contour mill cycle. And we have three basic contour milling cycles. We have path milling, pocket milling, so that would be irregular pockets, or boss milling or spigot milling, that would be leaving a boss standing. But in all of these cases, path included, I'm going to create some kind of irregular shape. So in this case, I'm going to create this outside profile. And the way that we do that is we're going to do that with a contour. So see where it says New Contour in the upper right-hand corner? You're going to select this button. You're going to give it some name. So the name is for your own reference. You can call anything you want. I'm going to call mine Profile. You're going to select the Accept key, and it's going to launch our contour editor. So this is how you start to draw irregular shapes at the control. The contour editors, the contours could have been imported from a DXF. There's a separate piece of software you would use to do that. It does certainly have that capability. So at this point, we're going to come in. We're going to draw the contour shape. So I'm going to define a starting point, and can certainly be, in this scenario, anywhere on the part, either the center of a point or anywhere on a given line or in a corner. I'm going to start from my corner. I'm going to happen to start from my lower left corner. So I know that the center is 0, 0. So I'm going to say I'm starting -2 inches down or over and -2 inches down. Give it the first starting point, hit Accept. Now I have a little orange indicator at that coordinate position. And now I'm going to use these symbols and my vertical soft keys to draw my shape. So I'm going to maybe move vertically straight up because I'm on the outside of my part and I want to climb mill. So I'm going to work around this part in a clockwise fashion. I'm going to move up to a Y of 2 inches, absolute. So this would be this upper left-hand corner up by this 5/8 radius. I'm going to come down to our transition to next element function, and this allows me to do either radiuses or chamfers between this line and whatever comes next. So in this case, we're doing a 5/8 radius. So once you fill out the event and hit Accept, you see it's going to start to draw for you. So you're going to have a concurrent draw as you go. So if you type in a number wrong, you'll immediately start to see it. So here we're doing a simple chamfer. Chamfer's 1/2 inch. Now I see my vertical, my horizontal. I had just hit the horizontal button to do that. Vertical, I'm coming back down. When I get down there, I'm putting a radius. Accept it. Now I'm moving back to -2 where I started from. You don't have to end in a sharp corner, so I can end at a chamfer and it will figure out automatically for you where we're going to start and stop. So here I drew my shape. Now what happened is it's created these little icons on the left side of the screen. And this is how you can keep track of all these events. So you can use your blue arrows. As I move the blue arrow up, you see how my highlight starts to change. So right now I'm sitting on that vertical or that horizontal line to the right. This is telling me that this is, and I see it's in orange, this is my element where I moved over to an X of 2. So maybe I put the chamfer in wrong. So to edit it, just simply hit your blue arrow to the right, the same way I do when I'm opening an event. And then you can come down, make a change, accept it. Now I see my change. Maybe that wasn't what I wanted. I could come back over, move down, type in the new change, accept it, and there we go. So whatever you do, you draw it till you get it complete. You do not have to go back to the same point. It doesn't have to be a full complete loop when you're doing profiles. If I had something in the way, this happened to be. But you get the elements the way you want it. You hit accept, and what it does is it stores the profile. So once the profile has been created, what's important here is you see this little like jog, or this little indicator that's sitting between this squiggly line and the N30. That indicator tells you that we need more information. So whenever we go into any cycler function that needs more information to complete itself, it's always going to show you this little open-ended bracket. So what it's telling you right now is you've given me a shape, but you haven't told me what I'm doing with the shape. Am I path milling, which is what we're going to do in a second? Am I pocketing, or am I boss milling? In this case, I'm doing a simple path mill. So path mill means I'm working on the wall, either OD or ID. I'm going to select my tool. So in this case, we're going to create a tool just so you can see quickly how the mechanism for creating a tool. So I'm going to go down to an open spot either in my carousel, or if you scroll all the way to the bottom, we have what we consider unloaded tools. So those are tools that you create that aren't necessarily in the tool changer at this point, and then you will load them in later. So wherever you want to create the tool, just find a spot that's not occupied. You're going to select New Tool, and this is the tool library of all the different types of tools we support, and there's a whole bunch of them in here. For what we're doing, we're just going to create a simple half-inch end mill. So I'm going to just leave it highlighted on the end mill, select OK. The cutter, you can turn on or off auto naming. Now, when it comes to the names, you don't have to abide by the same rules as far as file names. So you can use forward slashes, spaces. You can put all kinds of different symbols in here. You know, typically I'll use, a lot of times I will try to keep things consistent, so I may use underscores because I know that in the names I don't like to have spaces, but it doesn't really matter. The name here is strictly just a name. So we're going to say this is a half-inch end mill. Select my input key, or on my PC keyboard, my enter. I define the diameter of the cutter, in this case half-inch. I define the number of flutes. Maybe this is a 3-flute cutter. The default direction of the cutter. So this is going to be a cutter where I'm running the spindle in a clockwise direction, a standard lower right-hand cutting end mill. My coolant. So if I want coolant to be running for this tool. And the number of spigots, this can all depend or vary based on the machine builder as to how many different coolant functions he supports. In this case, we're going to just do flood. The second would probably be mist. Sometimes it's through coolant. There's a whole bunch of different things. But that's the basics to creating a physical tool. From here, I select the to program like I did before, puts the tool into my tool table. Now I can program either feet per tooth or inches per minute. Same thing with surface feet per minute or RPM. Once I define them, I'm either roughing, I'm finishing. If you have a chamfer cutter in there, it'll do a chamfer on any of these features. So we're just going to rough it. Do I want to follow the direction I drew the shape in, or do I want to go opposite? So maybe it's a case where I didn't pay attention when I drew it, and I drew it where I would be conventional milling, but I want to go the other way. Well, here you could just say, hey, go the opposite direction as to the way you drew it. I drew it going around clockwise, knowing that I was on the outside of the part, so I don't have to change that. I leave it forward. This is how I control my cutter comp. So cutter comp left, cutter comp right. No, I don't want to use cutter comp. Maybe we're doing some kind of like an O-ring groove or something. So we're going to use cutter comp left. The top of my part, so in this case it's Z0, right, because we already took off the 30 thou. So I'm starting at Z0. I'm ending, in this case, 787. That's what I said the overall width is. Certainly, maybe we can go a little deeper if I wanted to, because I'm maybe going to face off the part in the next operation. Depth per pass. So we'll just do this in a couple passes. So I'm taking a 1/2 inch. Whenever you see a U, it's do I want to leave material for a finished cut? So either in the Z or the X and Y. Now it's how do I lead onto the part? So do I want to come in on a straight move? Do I want to come in with a quarter circle? Do I want to do a full 180-degree arc leading in? Vertical is if I'm not using cutter comp, because I'm more walk right on the center line of the part. So that would only be if you're not using cutter comp. In this case, I'm going to do a straight move onto the part of 1/2 inch. I'm going to feed down at 20 inches per minute, and then from there, it's going to physically profile it at whatever feed rate I have in the top of the screen. When I'm done, I can either pull straight out or maybe use one of my arcs. So I'm just going to pull straight out at a given distance. And then here, the last question is, what do I do between passes? So do I want to always move up to my Z0 plus my safety distance? I had set that in my header page, 100 thou. Do I not want to do any retract? Well, in this case, I'm going to keep going around a couple times, so I won't necessarily need to retract until I'm done. Maybe there's something in the way, like a clamp. So maybe I want to jump all the way up to my retraction plane between each pass. But again, this is between each profile. So it's going to go around, then she would jump all the way up, go back to the start point, feed down to the next step, go all the way around. So I'm doing no retract. So I fill it out, I hit accept. All right, so now we have a few different things in the part program. So I do want to start to simulate it to see what's happening. So I'm going to select simulation. I see it face off. I see it start to profile. I can look at it in 3D. Now that looks like I had a typo because it's just continuing to go. All right, so let's take a quick look at my part. Oh, yeah, -8 inches. That's no good. Remember, I wanted 0.8. I missed my decimal point. All right, so we'll simulate it again. Simulation's a beautiful thing. All right, so now we come around it, I profile. And how did I catch that I made a typo? Well, right off the bat, I knew that I told it the stock was 1 inch, and I was only going down 787. So I was waiting to see the lip. When I saw it blow by the lip, I knew I had a problem. All right, so this is my basic profile. This is how simulation works. So when you first come in, it may be sitting at a top view. The 3D is an option, so you may or may not have that on your system, but it certainly can be added at any point. I can look at further views if I want to look at it from the side or maybe from the top. We can go back to 3D. I can zoom in or out by going to details. If you have a mouse on the system, you can rotate the models. You can do all kinds of neat stuff. You can also turn on path milling. So if I get back here and I hit the double arrow, you get to the show path field. And you can see the center line of the cutter or the path that the cutter would have to take. So this gives you a really good idea, especially with rapids and whatnot, if I maybe have clearance issues. Okay, so we're starting to see that this is starting to look like the part that I'm expecting. So now I'm going to jump back in and we're going to continue on. Somebody wrote in the QA, they caught my my 8-inch typo. Yeah. Okay. So I'm back. We're going to continue cutting. So now we're going to drill some holes. So I want to go over to the drilling area, and this is where all of our CAN cycles for drilling exist. So I can do center drilling, drilling reaming, which is feed to depth and pull out, or feed down and feed out. Depot drilling, which we'll use in a sec, which is my PEC drilling cycle. Boring would be if I had a boring head, and then the boring head would physically come down and bore out that hole. From there, you can have a lift or no lift strategy. So in this case, the boring bar would come all the way down, orient at the bottom, pull out of the hole. We don't have time for those examples. You can do all your tapping in here. Tapping, you can do single or PEC tapping if you wanted to. So here you see the tap will come in, back up, continue going. So what we're going to do is we're going to center drill and drill some holes real quick. So what I want to do is I want to go into my sew and center drilling cycle. I'm going to go to my select tool, find a center drill if I have one. I happen to have one right here. Define my feed rate, my spindle speed. And then how do I want to control the depth of the drill? So I can program based on the tip depth, or my true depth, and that would be based on the Z1. So now I might have to figure out how deep I want to allow that center drill to go. Or I can position based on the diameter. Now, these are spot drills, so this isn't like a combination drill. So this would be like a 90-degree spot drill. But what we can do is I can program that, hey, I want to go down so I have a spot face of a 375 diameter. And we'll automatically calculate, because when you create the center drill, you do tell it the tip angle. In this case, it was set up at 90 degrees. So we can calculate how deep the drill would have to go to get a 3/8. Now, this one happens to be 1/2 inch, so I can certainly get a 3/8 out of a 1/2 inch center drill. So I fill out the drilling cycle, I hit accept. See your little open-ended bracket? Just like before, this is telling us that we need a little bit more information. So now I'm going to then go and link this to some locations or positions. Now, this is where we start to differ. We do allow you to, when you have multiple operations on the same locations, we allow you to set up all of your cycles prior to the drilling cycle. You don't always have to do this, but if you have common operations, so I'm going to center drill and drill on the same bolt hole pattern, which is what we're about to do. Here I'll go into my drilling routine and then come in and set up the drilling routine before I call up the bolt hole pattern. So I go to select tool like we did before. I go and find a drill, which I don't believe I have a 3/8 drill, so we'll make one real fast. I'm going to do a twist drill. Drill is going to be 3/8. I'm not worried about my offsets right now. They'll get set up. I do give it the diameter. This is strictly for the simulation, just so you can see the hole and how big it drills. But the tip angle is critical. So maybe I know this is a 135 tip angle. Since I can program based on allowing it to compensate for the projection of the tip, I need to know the diameter and I need to know this tip angle so we can calculate out that distance. So we create the drill. I'm going to turn my coolant on, tell it to program. Now in drilling, I can program in either inch per minute or feet per rev. So not feet per tooth, but feet per rev. Same thing with my RPM or constant surface feed. Am I doing a chip removal? Am I pulling out a hole? Am I just backing enough to break my chip? So we'll do a chip removal. We'll pull out a hole. Am I positioning based on the tip? So I want to control the depth. Or the shank, and now in this case, it's going to go down to 787 plus the tip distance. My peck depth, so in this case I'm telling it I'm going to do a 1/4 inch peck that I'll pull out each time. I can reduce my feed rate, so our 3 thou per rev, I could say, well, go half that while I'm initially feeding until my first depth, and then after that it's going to do the program feed for the rest of it. You can decrement the peck depth. So at 100%, it's going to keep doing 250 to the end. But if I reduce this, it'll reduce the peck depth as I get deeper. So if you do deep hole drilling, this is very handy. Lead distance is my retract amount. So I can control that if I want as a set value, or I can just let it automatically define it. And then if I want to dwell at the bottom of each hole. So you fill out the CAN cycle again, just like the center drill. You hit accept. You see how they're still linked, but it's not done, because I do have to give it some positions. So I'm going to jump over to the position screen. That's at the bottom of my vertical soft keys. And this is where you tell it how you're drilling. I can do random positions, and certainly they can be, if I have a 4th axis machine, that could be around a cylinder, or X and Y would be flat random locations. I can do arrays of holes, whether it's a line, a grid, or a frame of holes. We can do bolt hole patterns. So in this case, I'm going to do a bolt hole pattern. So you pick the bolt hole pattern, you give it where the drilling starts from, where the center of the bolt hole pattern is, in this case 0, 0. Where the first hole is going to be, that's 0. The radius of the bolt hole pattern. Now, you notice on my print, we have 2 3/8. So if I need to do some math, I can do some basic math right in the field. Or on any field, if you hit the equals sign on your PC keyboard or on your keyboard on the machine, it'll bring up a calculator. So here I could have typed in my 2.375 divided by 2 equals, and you can keep doing the math and hitting equals, and once you get to whatever the end result you want, just hit accept. That'll also write it right into the field. Number of holes, how do you position between the holes? So is there a feature in the way? You want to follow the radius, or do you want to do straightest path? Fill out the page, hit accept. Once the brackets are complete, I can now simulate. So we'll go in and we're going to see it face off my part, profile my part, spot drill, and drill. Now you notice I didn't break through. I didn't break through because we only went 787 plus the tip distance. Now one way you could check that would be to go into your cutaway. And when you get into your cutaway, you can move around your cut. But I could have moved my cut down, so maybe just below this edge. Let's go down a little bit more. And you can notice now, you can see the tip. We could rotate it around. You could actually see that the tip edge in relation to the surface, even with that step. So that's where it went down to 787 plus this tip. That edge is actually a 0.8. Remember, I went a little deeper. So all kinds of different ways you can analyze the part through simulation. Now, there's only one thing that we haven't put in, and this is the counter bore. I like to always save this for last. So I'm going to go back to my part program. Now, just like my drilling cycles, I can continue to insert events here. So in this case, I actually want to mill. I want to do a circular pocket in place of just doing a simple counter bore with a counter boring tool. So I move the highlight just above where I want to insert this event. And now I'm going to go over to milling, and I'm going to go over to pocket. So this is unique to us. There's very few controls I've ever seen in the marketplace that can do this. And what we can do is we can actually treat all of our milling cycles just like drilling cycles. So if you have common milling routines with the CAN cycles, all I have to do is come down to this single position, select it to position pattern. Now all of a sudden a milling cycle is being functioned just like a drill would be. So in this case, I'm using helical cutter path. This would be like turbo milling, pretty common industry term. Centric would be more of your traditional plane by plane. What's the diameter of my counter bore? How deep is my counter bore? What's my step over as I'm moving out in the X and Y? Helical, I define the pitch. So as I helix into it, how much do I advance? Do I want to leave material for a finish cut? The point is, fill out the cycle, hit accept. You see how it shoves the circular pocket right into the drilling routine. So now I can counter bore all those holes with an end mill. Face off, profile, drill. There's your counter bores. Okay. So at this point, we're moving along nicely. I'm going to minimize our print. So the final area we want to talk about, and we'll just show you this real quick because we are running late on time, and I do want to be able to open up for some questions if anybody wants to hang out. I'm certainly not in any rush. But auto mode is how do I run the part. So you saw kind of how to set it up. You certainly saw a way to write a program with it. So the next step is, what do I do when I actually want to run it in automatic mode, and what are some of the features that Siemens has to offer here? So we're going to look at the display. We're going to look at things like distance to go while it's running, maybe bringing up basic blocks to see what move is coming up next. We're going to get a chance to bring up our simultaneous record to see graphics concurrent while it's running. We're also going to take a look at starting in the middle of a program and what happens and how can we start in the middle of a program. Okay, so let's jump right back to Sinutrain here. So I'm in the editor. We're still left where we were when we wrote our program. So the only thing I want to do is I want to move my highlight to my header screen. And now I'm going to hit the button in the lower right-hand corner, the execute button. What that's going to do is it's going to put me to auto mode. So if you see your highlight buttons here, the machine's currently sitting in jog mode. So once I hit execute, it's going to load this ShopMill sample program into active memory for running mode, for auto mode, and put the machine in auto. So I'm in auto. I see that the program was now selected for me. We're going to put on our workpiece display here. There is my part program. So now I simply hit cycle start if I was all ready to go, and it's going to start running the program. Now, the minute you start initiating it, it'll automatically bring up a distance to go field. Now, in conversational or ShopMill programs, you're just going to see the event that I'm in. And sometimes, you want to get a little bit more anticipation than just the distance to go, what's happening next. So that's an area where you can leverage the basic blocks function. So you see on your vertical soft key it says basic blocks. Simply click basic blocks, and then you see all of the resulting moves that are coming in the future. So you can kind of see what's about to happen before it gets there. All right. We can certainly control it with our feed, move it up or down. So here we're just going to fly through and drill the part real quick and do it. Now, with that being said, I can certainly have brought up simultaneous record. This is an option in our world, so you may or may not see it on the system. As long as you have it, I can now start running. And see, now everything's driving from my cycle start button here. So I start to see the base mill come down, my drill start to profile my part, or my end mill, shall I say, my drill start to drill it, peck drill it. I can slow down my feed. This is fully interactive and real time. There's my end mill pocketing. Continue chain just runs a little quicker than you would normally see on the machine tool. But this is your real-time simulation. Now, the other thing I do want to show you guys is how do I start in the middle of a part program. And there's two ways really to do it. One of the big reasons why I moved my highlight to the top of my program is when I do leave my highlight at some other location and I hit execute, it's going to initially want to try to start from that location. So that is certainly one way to start, is to just leave the highlight in the editor wherever you want to start from. And if you want to start right now, simply hit cycle start. It's always a 2-cycle start hit. This is a double warning, so just in case maybe you didn't realize that you left the highlight down. You do have a chance to cancel it by hitting reset, or I can hit cycle start again, and away she goes. She's cutting the part. So that's certainly one way. Now the other way is to use the block search function. So block search, I simply bring my cursor to the event that I want to start from. Now when you're starting in events like drilling, when there's a bunch of can cycles linked, you always want to start from the position screen. If you start from the can cycles, it'll tell you that it can't start from there. Because what happens is, when you start from the positions, and I do block search, and then start search, the system scans to that point, sets up any modal commands to that point, and now says, hey, I know there's 3 operations associated with this bolt hole pattern. Which one do you want to start from? So I could say, okay, I want to start from the deep hole drill. So I already center drill it. I paused it halfway through my deep hole drilling because I was getting some chip packing or whatnot. So highlight that, select OK. Then it even asks you which hole do you want to start from. So maybe I paused it the 3rd hole over, and that's where I want to start from again. I can tell it that. Now I select OK. The system sets that point, scanned any modal commands that happened earlier. It knows them all. So we can say, OK, I'm going to bring up simultaneous record so you can see it from a graphic standpoint. But here you would see double cycle start. Drill come over, starts drilling right at its 3rd hole. We'll move the feed right up a little bit. Drilling. There it goes in milling. So I don't have any profile because I started below that. I don't have my first 3 drilled holes because I started below that. So you can see it'll just start right from that point. Probably the only other thing that would warrant in our limited time to talk about is program controls. And this is simply how you get in, do things like initiate dry run. So whenever you initiate anything within this area, optional stops, you're always going to see the symbol come up. So dry run would obviously increase the feed rate significantly while it's going to execute the part program. PRT mode is an axis lock mode. So it would seem like the program was running real time, but the actual physical axes would not move. RG0 is very handy. That's a reduced rapid traverse. So maybe you're proving out a job and you don't want to let the machine run 1,000 inches per minute when it rapids. So you can hit RG0, and then it's going to decrease by a parameter. And I'll show you where that parameter is in a second. Optional stops, a hand wheel offset mode, block skips, and then single block. And single block is triggered by a hard button right here. But the mode, we have actually 3 different single block modes: rough, calculation, or fine. So fine is what you're used to. That's a single block, every single command. Calculation or rough, they'll allow like non-motion commands to pass by, so you don't have to hit your cycle start button 50 times to get through a feature until it's going to move the machine. So these just make single block a little more proficient. So that's how I would activate any host of those commands. Now, how I control what speed the dry run runs at or my reduced rapid traverse, what that is right here, if I hit this little arrow indicator above simultaneous record, on the machine panel, it's usually the gray arrow to the right of the menu select button. But that moves over or modifies my horizontal soft keys, gives me the settings button. Settings is where I can go in to tell it my dry run or my reduced rapid traverse. So right now, reduced rapid traverse was at 100%. So even if I turned it on, nothing would have happened. But if I type it 50, and it will retain this on power down and power up, then all my feed rates would cut in half and we'd be running at 50 inches a minute. All right, and to get back, we're back to the standard area. Okay, so with that being said, I'm going to open up the floor right now to some questions. I know we certainly used almost all of our hour and a half, and I had to kind of move it through the topic a little bit. There's a lot of content there. But I have time. I'm not in a rush. So if you guys have any questions, let me review maybe a few of them that came in. One question received from William, how would you set tools to the gauge line? Okay, so traditionally, when I'm establishing tools to a gauge line, what you're going to see here in the offset table, let me go back to the offset table, is a positive tool length, not a negative tool length. So generally what you'll do then is you're going to establish the gauge line of the spindle, whether it's the face of the spindle or on a Cat 40 it's slightly up from the face unless it's a big plus spindle. But that is established through a Z offset in the work coordinate system. So a lot of times, you'll come down and you'll set a Z0 to the face of the spindle, let's say, and have a large negative number here. And then you'll load a tool, come down to probably that same plane, so if it's the top of a presetter or a little LED block, and then you'll set the tool lengths with the measured tool function, just like I showed you guys. So in jog, I would use measured tool and my length, but now I would be, you can leave it at workpiece, it really doesn't make any difference what this says, but now I would be physically sitting above, my spindle face would be above the plane I just datumed under my set work coordinate. So now when I naturally touch that tool, it'll feed a positive offset. The other way, a lot of guys, when they do positive gauge line offsets, is they're working from a presetter. So if they're working from a presetter, the presetter would have told them what the positive length was. So they're just going to type these fields in. They wouldn't even use the measure tool function, but they are certainly still going to set a work coordinate. So there they would bring this tool. Maybe you had already had a gauge tool in the spindle. You could use that. That tool could be offset. But you'll come down, touch wherever you want to datum the surface to, and then establish a Z field or Z0 set. And usually, in most cases, I use my set work coordinate button for that and my Z here. It's a nice simple way to take either a known tool or just take the spindle, come down to a datum point where I want to establish everything from and zero it. So hopefully that answered your question, William. Let's see what else we have. The machine screen is a bit different than our machine. Is this a newer version? Yes, it is. So this is what we consider operate. Traditionally, in the older systems, we had what we called HMI, and HMI was either embedded or advanced. That was really more of a very kind of granular G-code looking control. There weren't a lot of these graphics and the stuff you kind of see here. And then with that, we had a ShopMill or a shop turn option that kind of overlaid on top of HMI advanced or HMI embedded. You didn't, or basic, sometimes they called it that. You didn't necessarily always know that HMI was running underneath, but it always was. So the ShopMill shop turn interface is really what operate, which is what you're looking at here, looks like. But what operate did was operate merged those two interfaces into one. So in the old system, if I needed to get into like system parameters and stuff, I would have to go to the HMI area to access parameters. Now, and what you're seeing now, which is our current control, I can just simply hit menu select, setup, and I'm in my parameter area. So this is what we call operate, and operate is the latest version of the 828 and the 840. All 828s are always operate. We introduced the control once we made the switch to operate. It's really 840s would kind of bridge the gap. So you had pre-operate systems in the 840s, and now all the new systems are what we call operate. And operate is really just the name of the software we're using. So hopefully that clarifies that. Michael, Michael, how you doing, buddy? Can we use a mouse on the machine? Absolutely. I have run into some systems where they don't always support the drivers, but typically they do. So yeah, you should be able to plug in a mouse right into the USB port. So I would absolutely try it. Certainly keyboards always work. Sometimes a mouse to driver, depending on the version or the age of the control, may or may not support. All the newer systems, I'm pretty sure, it does automatically. Okay. All right. Can the control be updated? It can. You do have to kind of watch that, however, because depending on what version you're going from and to, it may require hardware. And if it requires hardware, the price could be pretty costly for doing the update. Michael, I think you're referring to the Fryer systems that you have. In both of your cases, those are pre-operate systems. So with that being said, to match this, your NCUs would have to be upgraded. Pricing, I can't speak on, but certainly we could talk to Fryer, and they could probably come up with give you some baseline ideas of what the cost would be for that. Okay, so if anybody else has any questions, by all means, feel free to type into the Q&A panel. I know we've gone pretty late here. All right. Well, it looks like we're in pretty good shape here. So what I'm going to do now is I'm going to end our recording. We're 1 minute and 27 seconds. Oh, we got one question in. How do I create variables in the MGUD area? This is from Jesus. I would suggest, Jesus, that is a little bit more detailed. Why don't you reach out to me offline, and we can talk about that in a little more detail, because that is more of a commissioning scenario. Okay. Well, hopefully everybody found this to be helpful. I am going to end our recording now. All right.